Hi, my name is Ifat Afek. I'm the PTL of Vitrage project. I'm going to show you today a demo of Vitrage main functionalities. Vitrage is Openstack engine for root cause analysis. It is used for organizing, analyzing, and visualizing Openstack events and alarms. The first use case is the deduced alarms and deduced states. Currently, Openstack projects do not have full visibility of the states of their resources. For example, in case there are memory problems or CPU problems on a certain host, instances running on this host will suffer from suboptimal performance. Nova will not be aware of it, and the states of these instances will be running. Another example, in case of switch failure, instances running on a host attached to the switch may be inaccessible, and yet Nova will not be aware of it. In Vitrage, we can identify these cases and raise deduced alarms on these instances. In addition, we modify the states of these instances to be error or suboptimal depending on the case. Another use case is the root cause analysis, where we can identify that a certain alarm is the root cause of other alarms. Vitrage is based on a graph database that holds resources and alarms coming from various data sources. Vitrage pluggable model allows writing plugins to get information from different data sources, and we currently have support for Nova, for physical topology from YAML configuration files. We get AODH alarms and Nagios alarms. We are writing Cinder and Neutron plugins, and we plan to add more plugins like HIT, Monasca, Zabbix, and others. We also have Horizon UI for seeing all these features. You can see in this example, we have a graph database that holds Nova resources and a physical switch. Assume that we get a Nagios alarm saying that there is a switch failure. We deduce, based on templates that I will show in the demo, that there must be a problem with the instance. We raise a deduced alarm on the instance, we modify the state of the instance to be error, and we mark that the Nagios alarm is the root cause of the deduced alarm. This is Vitrage architecture. Vitrage graph holds all the resources and alarms that were retrieved from Vitrage plugins. Vitrage evaluator is responsible for the logic. It reads template configuration files and decides when to raise deduced alarms, when to modify states of resources, and when to mark root cause relationship between alarms. The notifiers notify about Vitrage alarms and Vitrage deduced states, other external projects. We also have API, CLI, and UI for all these features. What are we going to see in the demo? We are going to see the cloud topology based on several plugins, Nova, Nagios, AODH, and physical topology configuration. We are going to see deduced alarms based on Nagios alarms and the topology. We are going to see deduced states, root cause analysis, and the UI and CLI of all these. Let's start by looking at the cloud topology. In Vitrage tab, you can see that now everything is okay. This is a sunburst representation of the cloud. You can see, for example, there is one availability zone, one host, two virtual machines. I can drill down to the host layer, and I can see information about this host, and that currently there are no alarms on the host. I'm going to create an alarm on the host. I will switch to Nagios. We are using Nagios monitoring tool in order to monitor the physical layer, and now I'm going to simulate a situation where there is a memory problem on the host. After refreshing Nagios, we can see that the memory use test is in a critical state, and we can go back to Vitrage and see how it affects Vitrage. In Vitrage topology, we now see that the host is in critical state. There is a critical alarm on the host, and if we drill down to the instance, we see the instance in suboptimal state, and there is also an alarm on the instance. The alarm on the instance is deduced from the alarm on the host. We understand that if there is a critical memory problem on the host, there must be a problem on each instance running on this host. So we set the state of the instance to be suboptimal, and we raise an alarm, a deduced alarm, on the instance. We can go to the alarms list, and we can see over here 3 alarms. One of them is Nagios alarm. it's a critical alarm, memory used, and there are two deduced alarms, which are Vitrage alarms. If I go to Nagios alarm, I can open the RCA, the root cause analysis. I can see that the memory used alarm caused two alarms on the instances. I will now remove the alarm from the host. I will go back to Nagios and set the state as OK. So we can go back to Vitrage and see that the alarms were disabled and everything is back to normal. There are no alarms in the list. And the topology is green again. Now I'm going to demonstrate how a switch failure can affect instances running on a host which is attached to the switch. Switch information is not part of Openstack components. Vitrage has a plugin which is called the static physical plugin, where it is possible to define the physical topology in YAML configuration files. Here in this file, you can see that there are two switches defined, a public switch and a private switch. Both are attached to the host. I'm going to call Vitrage CLI to show the topology. So in the topology, there is the host. Its type is Nova host, and it's running. And there are instances, Nova instance. And there is the public switch of type switch. And there are the relationships between these entities. I will now go back to Nagios and simulate a switch failure. Now this test is in critical state, and we can go back to Vitrage and see how it affects Vitrage. In Vitrage topology, you can see the instances are in suboptimal state, and there are alarms on the instances. We will go to the alarms list. And again, if we open root cause analysis for the Nagios alarm, we can see that the Nagios alarm is the root cause of two alarms on the instances. In addition to Nagios alarms, we also have alarms coming from AODH, Ceilometer. So now I'm going to demonstrate how we create alarms in AODH and how we see them in Vitrage. There are currently no alarms in AODH. I'm going to create two alarms. One is a threshold alarm, saying that if the CPU is above 10%, raise an alarm. The other one is an event alarm, which is already triggered. You can see these two alarms in AODH. Now I'm going to call Vitrage CLI in order to see all Vitrage alarms. You can see there are 5 alarms in Vitrage. One is Nagios alarm. There are 2 deduced alarms on the instances and 2 AODH alarms. And of course, we can also see these alarms in Vitrage UI. So there are now 5 alarms in Vitrage UI. I can sort them by the type. I can filter. I'm now going to show how to configure the behavior of when to raise the deduced alarm or to set the deduced state. For example, we will see the use case where there is a memory problem on the host, and as a result, we raise the deduced alarm on the instances. So in Vitrage, you define this behavior in template files, which are YAML files. Every template has a few parts. The first part is the entities definition. We define an alarm, memory used. We define a resource of type Nova host and instances. Then we define the relationships between these entities. For example, alarm on host or alarm on instance. And then we define scenarios, which are, every scenario has actions to be taken. So for example, the condition is alarm on host. So we have an alarm of type memory used, and we have a host, and the alarm is on this host. In this case, we want to do set state of the host to be a role. Another scenario is we have an alarm on host, and the host contains an instance. So for every instance that this host contains, we do two things. One action is raise an alarm on the instance. Another action is set state of the instance to be suboptimal. The last scenario in this template is in case we already raised the deduced alarm. There is the alarm on host, and the host contains an instance, and there is an alarm on the instance. Then we want to add causal relationship between the host alarm and the instance alarm. This causal relationship is another edge added to Vitrage graph. So later on, when someone wants to query the root cause analysis of the instance alarm, we don't have to calculate it. We already know that these two alarms are related to one another. Vitrage will be released with a large set of predefined templates, and it will be very easy for anyone to modify these templates or add new ones. To summarize, I demonstrated today how Vitrage can be used to connect the physical layer to the virtual layer, to deduce existence of problems in the virtual layer from failures on the physical layer, and to show clearly the root cause of problems. Thank you.